Welcome to my talk about osm2pgsql. My name is Jochen Topf. I'm a freelance software developer and consultant specializing in OpenStreetMap data processing. osm2pgsql is a tool for importing OpenStreetMap data into a PostGIS database, and if you want to keep it up to date there from changes in OSM. It has been around since 2006, and I've been working on it since 2019, and I'm the person doing most of the development at the moment. The tool is written in C++ and is available for all major platforms. The main reason osm2pgsql exists is to create maps from OpenStreetMap data. We import the data into the database and then have lots of tools that, and you might know a lot of them, that can be used to create maps from data in PostGIS. It's not the only reason, but this is how osm2pgsql was started. And this is the map that started it all. That's the map that you can see if you go to openstreetmap.org, so-called OpenStreetMap Carto map. This is still run from osm2pgsql. But this is not the only map in use today, of course. There's lots of other maps that take OpenStreetMap data and do some specialized things with it, and this is where PostGIS and osm2pgsql shine. For instance, this is a railway map that takes OpenStreetMap data about railway infrastructure, about signals, about lines, and how electrified they are or not, and all this kind of information, and loads it into a database and then creates specialized maps from it. Another example is the Open Camping map that takes information about campgrounds and turns that into a specialized map again. Here's another example that I created from data in PostGIS using osm2pgsql data in PostGIS and created vector tiles from it. But it's not only maps. You can use the data obviously for lots of other things, for instance for search. This is the Nominatim search that you find on openstreetmap.org, where you can type in a place, in this case Antwerp, and it'll find the place for you and put a marker on the map. Nominatim also uses an osm2pgsql generated database with lots of extra processing on top of it that are done in the PostGIS database. So why do we need a specialized tool for that? There are other ETL tools that you can use to import OpenStreetMap data into a database. For instance, OGR has functionality for reading OSM files. So you could use those also, but there's several reasons which make osm2pgsql the right tool for these kind of jobs, and I'll go through all of them. First, it understands the OSM data formats in detail. OSM data doesn't come into the normal simple feature data formats. It has its own sort of idiosyncratic format with nodes, ways, and relations. Nodes are basically points, so they have a location and they have one or more tags or zero or more tags that tell us what this node is about. So here, for instance, maybe this red dot is tagged as amenity restaurant, which means it's a restaurant, and other nodes have tags, or maybe they don't have tags. So in this case, the gray nodes don't even have tags. They are only used as points for what we call ways. So to make up a line string, for instance, you basically need a way. The way points to the nodes it goes over, and then has tags again here. In this case, the blue way has the highway primary tag. So it's some kind of major road and a name. And the other ways here might have different highway or other tags. This whole thing builds a topological model where you can actually route over the lines. You know when two lines cross, if there's a node that connects them, then that means there's a connection. If there isn't, then there is no connection at that point. It might be a bridge over another road, these kind of things. Or you can, for instance, have here this barrier gate. So the node is tagged as barrier gate, and the node is part of the way, so we know that there is a gate inside on this road that can block the traffic there. And then we have something called relations. Relations connect other objects. They connect nodes, ways, or other relations into a bigger object. In this case, we might have a hiking route, and the hiking route goes to the blue way and the green way and the black way, and connects them all to one longer route. So there could be a hiking route or a bus route or something like that. But relations are also used to create multi-polygons, for instance, or to give other information. So as you can see, this is a very different model than the simple feature model that you know with points, line strings, and polygons, and multi-points, multi-line strings, and multi-polygons, and the normal sort of Postgres. In Postgres would be tables with columns or layers and attributes that you have in a shapefile or in other kind of GIS formats. A second reason why osm2pgsql is a good tool for this kind of job is it scales from very small extracts to the full planet. So you can use data just for a single city or something, and use osm2pgsql to import that data into a Postgres database, and it will just take a few seconds. Or you can get all the data from OpenStreetMap for the whole planet. At the moment, that's more than 1.4 billion objects, and import them all into a database. And you don't even need a huge machine for that. 128 gigabytes of RAM you need for this task, and 1 or 2 terabytes of SSD, depending on configuration, all that. And it will take 6 to 12 hours, something like that, depending again on many configuration options and your hardware. What is also different is that osm2pgsql can do updates. So you can import the OSM data and then later on keep up with the changes that come into OSM, and there's changes every second. Something is changed somewhere on the planet, and you can push them all into the database piece by piece. So this is how it works when you're running osm2pgsql. You call it on the command line. You give it the database name, so it can connect to your database, and some extra information if you have a password or these kind of things. You have to switch it to flex mode. The tool has been around a long time, as I said, and we want to be backwards compatible. So the same command line that you could run 10 years ago, you can still run today, but nowadays you don't want to use the old mode that was pretty limited in what it can do, but use the flex mode. So you give it a command line option -o flex, and then you give it a config file and the input file, the data file from OSM that you want to import. If you want to have updates, you have this extra option --slim. Again, one of those old options that doesn't make much sense, but it basically means this is an updatable database. And then it imports the data in a specific way and stores some extra information in the database that are needed to update the database later on. And then you can initialize the replication process. There's a specialized tool called osm2pgsql-replication that comes with osm2pgsql, and it will orchestrate the whole update process. So you initialize it once, and then you run it every minute or every hour, or how often you want to do the updates, and it will automatically do the right thing, download the right data from OpenStreetMap, and push it into your database. And osm2pgsql is highly configurable. It can do a lot more than other tools can to bring the data into the database in the form that you need it. And the way it does that is by using the Lua configuration language. Lua is a programming language often used in games or for writing the game logic. And it's easy to integrate into a C++ program. That's why we're using it. This configuration file that you create using the Lua language has basically 2 parts. You set up everything once, and then you describe how the data processing is supposed to work. So setup means you define the tables with their column names and the types of the columns and these kind of things. And you define indexes and some other things. And this is sort of similar to what you would do with a create table command and all these things, but it gives some extra information to osm2pgsql. Here's an example how this could work. When I created this talk, it was Halloween, so I created this, decided to create this zombie table that shows all the areas, or so will later show all the areas where there are zombies. I want to have two columns, a name column, that's just a text column, and a geometry column called geom, that's a geometry column with a polygon type. And I could add here more information like which projection to use, so I could use the SRID or some other information in here. And I define this as a table, and as I want to store ways in that table, that is important so that it works with updates, and keep a handle to this newly created table called zombies, and this so that we can later refer to this table when we fill it. The second step then is to define how each and every node, way, and relation is to be handled. osm2pgsql will read the OSM data file and to handle each object piece by piece, go through all the objects, look at each object and give it to you for data processing, and you decide what to do with it. So in this case, we are looking how the processing for ways works. So this is a process way function that you define here. And we know that there's two different ways of tagging a cemetery. In OpenStreetMap, it can either be tagged as land use cemetery or as amenity graveyard. So we check for these, for one or the other of these tags. Then we take the name tag and we exchange every letter O in that name by this jack-o'-lantern emoji. And then we can insert this into a database. So we're using again the zombies variable that we defined earlier that gives us information about the table that we have created above, and insert the data, in this case the changed name, and we create a polygon from this way and put that in the geom column. And this is the way to tell osm2pgsql how to do the processing. So you always have basically these different steps. You select some kind of interesting data by looking at the tags. So if you want to find all the highways, you say let's see everything that's tagged as highway, and then you clean up the data, you transform it in a suitable form. So for instance, you might say for the highway data, there's a max speed tag that gives you the information how fast you are allowed to go on this stretch of road. And if there's no unit and it's just a number in OpenStreetMap, then that means kilometers per hour. But if the max speed is given in miles per hour, then it will have the information MP or the unit MPH in it, and you can figure that out and then transform it and say, okay, multiply it by 1.6 so that you get the kilometers per hour or whatever you want to get a form that makes the data easy to use then later on for whatever your use case is. And then you create the proper geometry, in this case a polygon from this way, but if you have with cemeteries, we created a polygon. But if it's a road map that you're interested in, you would create a line string from the way, and so on, and write this information then in the right database table. There's a lot more geometry processing that osm2pgsql can do. We can project into any projection that you want to. We can simplify the data or merge lines or calculate the length of an object, calculate a centroid of a polygon. This is only sort of the most important geometry transformations that you often want to do when using OpenStreetMap data. It can't do everything that PostGIS can do, but we're importing the data into PostGIS, so there's a lot more that we can do afterwards, just sort of the most important stuff that we often want to do, we can do in osm2pgsql. There's some more stuff I want to talk about. Locators, about tile expiry, and about data generalization features that are in osm2pgsql. Locators is a new feature just added in version 2.2.0. It allows you to find out where an object is. Basically, it feeds all the data, all the objects from OSM through a point in polygon check. So you give it a list of polygons, for instance, a list of country polygons or states in the US or something like that, and it figures out where exactly the data is. And then you can use this, for instance, if you want to have high-value shields on your map, you need to know in which state something is, so you can use the proper high-value shields with the proper symbols. But there's many other use cases, and it's a lot faster to check OSM data against this list of polygons while doing the import instead of doing this afterwards in PostGIS, which is of course also something you can do. And then there is the tile expiry. In many cases, when you want to create a map, this will be a tiled map, either a raster map or a vector tile map. So if something changes when you do updates, you want to figure out which tiles do you have to re-render or reprocess in some way. And that is what osm2pgsql also can figure out for you and store this information in a database table or in a file. And then there's the issue with cartographic generalizations. If you zoom out, you can't show all the information. Of course, you have to do some kind of generalization. And osm2pgsql has several functions for helping you with that. So for instance, you have here on the left some forests maybe, and they are mapped in a lot of detail. osm2pgsql can take this information, render it into a raster map, simplify the raster map, and then create vectors again from this simplified raster map. It's a lot faster than to do the same thing with buffers in vector space, and you can do very fast generalization of this kind of land use data, this kind of polygon data. But there's some other algorithms built in. So for instance, when you create a map, you have to decide which labels to show on which zoom level. And so for places like in this map, it is sometimes difficult if you just have a absolute measure saying show all the places where more than 1 million people live or whatever it is. Then you get clusters of labels in one part of the map and no labels in other parts of the map. If you want to have a more even spread, there's other algorithms to do that, like in this map that I created here, that are built into osm2pgsql. This cartographic generalization, there's basically two ways of doing this. You can either trigger some SQL commands and do the processing in the database, or as I mentioned with this other examples, you take the data out of the database, process it externally, and then write back the generalized data into the database. And this is tied in with the expiry, the tile expiry that I talked about before. So it can figure out that something changed in this area and recreate the generalization for this tiles that will be affected. This generalization is still sort of beta and is not integrated 100% with osm2pgsql, but there's a separate command, osm2pgsql-gen, that does this functionality, but it reads the same config file, and once we get some more experience and some more people using it, we'll include that and bring it into the main osm2pgsql program. So all of this sounds like a lot of work. You have all these many different configuration things you have to write for every layer that you want to create, for every database table you want to create. You have to write all of this. But in many cases, there's somebody else who already wrote part of the configuration. So somebody might have written a mapping from OSM data to create a highway network, and somebody else created something to have land use information or something like this. And there's this added theme park framework that is basically some extra Lua code that helps you mixing and matching different kinds of configuration. If you write your config files in a certain way, you can bring in several configurations and create some larger configuration out of that. So have a look at the theme park framework also. That might be interesting. If you're using osm2pgsql or using OpenStreetMap data in general, please consider supporting OpenStreetMap, the OpenStreetMap Foundation, or maybe some local chapter, and consider supporting osm2pgsql. It is open source, and OpenStreetMap is all open data, but it still costs money to create all of this. Thank you for your interest.